All right, everyone. Hello and welcome. Before we begin, I'd like to note that tonight's talk is being recorded. My name is Svetlana Yashkova, and I have the pleasure of serving on the advisory board of the Carolyn Campagna Kleefeld Contemporary Art Museum at Cal State Long Beach. We acknowledge the Tongva peoples as the traditional land caretakers of the Los Angeles Basin and Southern Channel Islands, and are grateful to have the opportunity to work for California State University Long Beach at the sacred site of Puvunga. We pay our respects to the ancestors, elders, and our relatives and relations past, present, and emerging. I'm excited to have Doris Sung as our speaker this evening, kicking off the Material Concerns lecture series. The proceeds from this series help support the Kleefeld Contemporaries Collections acquisition. We will share a slate of potential acquisitions in the late winter with you, the lecture participants, and members of the public to offer feedback on which one or ones they'd like to see acquired. And if you received a ticket as a gift to this lecture tonight, I ask that you please consider making a gift to our museum for $5 or more. There's going to be a link in the chat for that. Finally, I encourage you all to check out our YouTube channel, Kleefeld Contemporary, and our Instagram at the Kleefeld. For tonight's lecture, I ask that you please stay muted while Doris speaks. And after the lecture, there will be a Q&A portion where you will have the opportunity to ask questions. And now a little about our speaker. Doris Sung brings active systems to sustainable design far beyond the simple greening of a building. With the belief that buildings can be sensitive to the changing environment, like human skin, she seeks ways to make the building skin dynamic and responsive. Through grant-funded research, she is developing smart materials such as thermobimetals to ventilate, self-shade, self-structure, self-assemble, and self-propel in response to changes in temperatures, all with zero energy and no controls. More recently, she is rethinking the liminal surface of the facade as part of a city's infrastructure and designing innovative building products that will improve public health for pedestrians in addition to that of the building occupants. Juggling between research and teaching at USC, Doris publishes, lectures, and exhibits internationally while managing to bring her patented inventions to the market. Her TED Talk has reached 1.25 million views, and she has received numerous architectural design awards. Doris received her Master of Architecture degree from Columbia University and her BA from Princeton University. Please join me in welcoming Doris Sung. Oh, Doris, you're muted.
Wow, that's like the typical, that's the standard thing of Zoom right now. I think you're on mute. Thank you very much, Svetlana, for that introduction. And thank you to the Carolyn Campagna Kleefeld Contemporary Museum of Art, that's a mouthful, for inviting me. It's really great to be here and to share my work. I'm going to share my screen right now. Give me a second here. And let me put it on the slideshow. So I hope you can see my screen. In order to prepare this lecture, I decided to talk about many different things. And a lot of it is because I get some common questions. And to preempt some of those questions, I figured that I'll try to address some of them in the lecture itself. What I'm going to talk about is I'll talk about a little bit of my background and how I came to where I am and why I think this way. I also talk about some of the influences of current culture or current things going on. And I'm going to try to mix these all together so that you can see how it becomes a much more comprehensive package as opposed to something that's a focused, pointed thing that I'm going after. It's actually multivariable and multifaceted. So I call this lecture Smart Boxes and Other Projects of Wonder because I do want to show you some of the projects that led up to this one. And I will focus on the one that we're installing right now in greater detail. So when I started college, just to give you a little background, I actually wanted to be a visual arts major, and my parents said, absolutely not. There's no way you're going to get a job. There's no way we're going to pay for that kind of education. So I had very little choice on that. But what I did was I very subversively took a studio art class every semester I was in college and every semester I was in graduate school. And I never told them about it, but I just did it in such a way that it was almost like a minor regardless. And what I ended up doing is I majored in biology because that was another big interest of mine. I was very science oriented. And back then there were very few science majors except just biology, chemistry, and physics. So biology was the one that I really enjoyed, the behavior of animals, cellular biology, all the way to ecology and behavior systems. And so that's why I show here even one of the favorite animals of mine, the pangolin, and you'll see how this starts to appear in some of my work. And I also really start to think about the combination of man coming together with this biology of nature and the control of man. And you can see in these very beautiful photographs and beautiful structures, the infrastructure that held these skulls, right, or parts of it, and how beautiful they actually were, and how over the history of myself and how I thought about this was waffling between how much we as humans start to impose ourselves on these ideas and artifacts. So when I got to graduate school, I actually started to think very carefully about these inanimate objects or these inorganic objects and how they become part of our organic body. So in this idea of a prosthetic device is pretty obvious on the left. It becomes absorbed into your body and becomes your leg or foot. And in this artwork by Rebecca Horn on the right, these elongated finger gloves, the more you use them, you can imagine the better you get at it, not only in dexterity, but you could actually extend sensation through the fingers so that you can actually feel things, you know, the shape of it, how rough it is, how soft it is, how deep it is. All these types of things are extended through an inanimate object. And so my question when I got to graduate school was, why can't architecture do this? Why can't we actually have architecture that can be an extension of our body and ultimately sense things? Why did we have to?
Sorry, I just want to mention that your presentation isn't.
Oh, it's not.
Yeah.
It's not progressing. Okay, sorry about that. I don't know what is happening.
Doris, go back to share screen.
Okay.
And stop sharing.
Mm-hmm.
And then share again, and it's going to give you the option of what to show.
Yeah.
And maybe just try showing the desktop instead of just PowerPoint.
Okay.
Let's see if that works.
Okay, so you can see my
Boom.
desktop here, right?
Yeah, and then make it full screen.
I think all I could do right now is pull it this big. I apologize. Should have stopped me earlier because now.
Or you could hit that green button and yeah.
Okay. Okay, so you missed a whole bunch of slides. They were great. Okay. Without going back through it, you know what I mean? Again, thinking about what I said about, you know what I mean, the artwork. This is a piece that I did. Can you see it? Or should I? Let me try to do. Let me try one more time. Tell me if I'm not progressing through it. Can you see?
Now it works. Yep.
Okay. So this is artwork that I did in college. Again, I'm not saying it's good at all, but I did it. The biology that I was a major in college, very infatuated with. The connection with man, right? The artifact, the man-made versus the nature-made. And the extension and the prosthetics of the human body, right? So the Rebecca Horn, the fingers, the sensation extended through the inanimate object. And then the question ultimately of why can't architecture be like that? Why can't architecture feel things, or why can't I feel things through the architecture and it be dynamic just like my own body? So even in graduate school, I actually built this in grad school. It was also this mechanical device that moved and responded to my face. So ultimately what I did is I designed a mask, not that it was for a death mask, but was a lock system that made my face the key. I continued doing work like this for about 10 years, trying to figure out what that connection was to simulating the human body in many ways. But then about in the early 2000, came upon writings by Elizabeth Colbert, and it was before she actually published this book. She published many chapters of it, and it was about climate change. And it really affected me a lot and influenced the way I thought. And I thought, wow, if architecture is going to survive, it has to survive climate change. And if the climate's going to change, architecture also has to change and respond accordingly. So then I started thinking about how architecture needs to be dynamic, and somehow it cannot be as stiff and static as it is now. I started looking at different precedents and how smart they were, something like the Igloo, which is brilliant. The shape of it allows the wind to go over it and pass and structurally be completely sound and span a space inside. The blocks are filled with air, little tiny air bubbles, and insulate quite well. And on the inside, when it's hot and you have the fire going, it melts the ice and freezes it up so it seals all the cracks. So it's actually surprisingly warm in the end and a very renewable material. It's the same thing you could see with yurts and the use of goat skins or the felts from animal fur. And the fact that it's mobile, it's lightweight, it's extremely insulating, it's waterproof, and it's also breathable. And so I also thought, why can't that skin, again, as an introduction, be like human skin? The human skin, keep in mind, is the largest organ on the body, and it's the first line of the defense. It basically does so many things, like containing your body, waterproofing again, controlling the heat, by sweating, by having goosebumps when it's too cold, all these different things so that the heart and the lungs don't have to overwork. And so the idea that I had is, why can't the building skin do this so that the heating, ventilating, and air conditioning system did not have to overwork? So I started looking at smart materials and smart things in buildings. This is probably in about 2005. And this is what you get, right? Basically, there's a lot of gadgets all over the house, and this is considered a smart house. But the reality is the roof, the walls, the floors, they're all exactly the same. They have changed nada over all these years, and they have not actually become smart. It's just gadgets. So I started looking at smart materials, thinking that this would be a source for it, and basically found that in engineering terms, a smart material is something that responds to changing conditions in their surroundings, and they require no energy and no control. So it's very, very different than, for example, a smartphone or other smart devices that are reliant on electricity, batteries, and computer systems or microchips. So the smart material that I found and I started using is a thermal bimetal. Basically, what happens is as the temperature goes up, it curls, you can see here. And what it is a lamination of two different alloys of metal together, and they have different coefficients of expansion. So as the temperature goes up, one side expands more than the other, and therefore the result is a curl. I also combine these things with geometries. You can see here, this is an image from, I think, in elementary schools in France from probably the 30s that delineate the different geometries that we all know and recognize. And then nowadays, with the use of computation and things that are much more complex, we are able to look at geometries that are just more surface-like, or actually what's called minimal surfaces. And you can see here, they become much more complex and therefore have a different kind of structural capability of them. And they are also efficient with the use of materials by looking at some of these different curvilinear surfaces. So you'll see some of this also in the work that I do in both of these boards. And ultimately what I do is I try to look at these smart geometries, use them for smart applications, smart assemblies, and develop smart systems. So I'm going to start showing some of these to you now. The 4 areas of current culture that I divide these in is in social conscience, economy and efficiency, climate and engineering, and health and wellness. And I do this not because they're actually very distinctly categorized into these areas. I just do this to kind of highlight some of the things that are on my mind and concern nowadays. So the first I'm going to talk about is social conscience. This was an article that came out this summer in the New York Times, or it actually wasn't a single article. It came out in 7 days, and it was all about women and women issues and the biases. And I thought they were actually quite good as articles, because even as an architect, it pointed out the things that we as architect can do. One of them, for example, that seems obvious is, and I'm sure everyone knows this, everywhere you go, there's always a line outside the women's bathroom. And you always wonder, why aren't we putting in more toilets or stalls in women's bathroom than men's bathroom? And a lot of this is dictated by code or by the developer trying to minimize the numbers to the minimum. And so the code itself is biased towards men in that way. So is the temperature in a building. Women are always colder in buildings than men. And so it's set actually at the temperature that's comfortable for men. And there's several things that, you know, when you really start to think about it, which I never thought before is something that architects should do. And so then I started thinking in my own work, how does this actually influence it too? I never did before too, because again, keep in mind in the world of architecture, only 19% of licensed architects in the US are women. And since I kind of grew up in this environment, it never struck me as being that different. Nor did I ever stop to think about how women should design, or if products designed by women should be any different. And so when it came to starting to build some of these things that I do, you know, when I started to look at them, I realized there's a certain amount of femininity to it, even though the materials may not be. And so in this case, in this project, I even chose a pink string and named it Armored Corset, just because it had this kind of reminiscent value to it. So you can see it in my own work that I start thinking about these names and trying to reflect on what those things are. Whether they are true or not is something that goes on in my mind. So this is the first project that I did out of thermal bimetal. And you can see on the left, the idea is that it would be a ventilating surface. And when it's cold, it'd be a very taut, flat surface. And when the temperature rise or went up, the air would be able to pass through the surface. It was also a very innovative time in 2009, because we used a very powerful computational software that basically parameterized each of the pieces so that each piece could have the same basic rules, but each and every piece is different than the next one, so that it can take a different form. And we combined it with a slot and tab type of connection, so we can remove all structure and make it a complete and continuous surface. So you can see here in a sequence from left to right, the cold being on the left and the right being hot, how the surface actually distorted to allow the air to go through. So that was very exciting for us, because again, keep in mind, this material has never been used in a surface ever before. The place that you'd actually see this material, just to let you know, is as a coil in a thermostat, only in these little tiny strips as actuators. So when I started looking at the material, I thought, well, why can't we use this as surface? Because we need to use it as surface as an architecture. What we call tessellation, which is again the tiling of all these small pieces, is a necessity, because the material comes in these narrow rolls, and you can't just roll out a very big surface, nor can you get shapes out of it. So by making it into different tiles, we can get the shape. And so you can see even here in this fish, or the scales on a fish, they also are parameterized, that basically they have the same properties in each of the scales, but depending on where that scale is on the fish, it differentiates in size and overall dimensions. But to the next one, there's a kind of gradual scaling, no pun intended, scaling of these scales as they go from front to back. So these things also occur in the work that I do, this kind of scaling or tessellation. In this piece, it was done in 2011. We used a different type of software again, which again was what has helped us and allowed us to make these things in a very parametric way, which I just mentioned. This piece was in Silver Lake, was installed, and I installed it because I wanted to know how this material would behave on the outside. Because again, keep in mind, my intention is to try to see how we can change architecture with this material. And as long as we kept it indoors, I didn't want it to stay in the world of interiority. I wanted to get it on buildings and to the skin of buildings eventually. So you see here, it was a very big sundial. It's about 21 feet at the front end, and it drops to the back end to a lower level of, I think, about 9 feet. I mean, the idea mainly was to sunshade in this case. As the sun was exposed, it would behave differently, and as it disappeared, it would close up. As I mentioned before, we connected it to various different computational software that allowed each of these pieces to be either longer or shorter, depending on where it was on the structure. We connected it to other analysis tools. In this case, you'll see the red is where the sun actually penetrated the surface quite a number of hours a day. In the blue areas, it was always in shade. So we realized we didn't have to use as much material in the blue areas because it would never react to anything because it would never see the light of that day virtually. So you can see here the variation and the night image on the right, you can see it's almost translucent because we removed a lot of material. On the left, it's quite heavy. A lot of the materials are very long. And you can see in this time-lapse video, over the course of the day, as the sun comes across the surface, all of a sudden it cooled them down tremendously and all the pieces start to shut down. So this was a very big deal for us in a January day, of course, in Los Angeles, that something like this happened. So we were very encouraged to know that we can possibly work it on architecture and this material can react to the sun. We also look at things of economy and efficiency in a different way too, right? Another book that influenced me quite a bit is Cradle to Cradle. This idea about circular economy and this responsibility that was much bigger than just recycling and saving energy. Tried to look at how we can think about making things efficiently, using less skill, and in hard to reach places. So in this case, use a much thicker thermal bimetal that reacts at a higher temperature. So in this case, we heated it up to about 250 to 300 degrees. If you do that, the material that is really hard to curl by hand when it's cold, because it's that thick, curls very nicely. You can slot it into something, and as it cools down, we constrict it into shape and make what's called a pre-stressed surface. It's very lightweight and very strong. And so the proposal that we made was for MoCA in 2013. And they commissioned us to do a pavilion for an exhibit there. But it turns out that that was a really bad summer for MoCA. They almost closed down, almost went bankrupt. It was a very difficult time and the project was never built. But the good thing is it was picked up by the Museum of Contemporary Art in Santa Barbara. We decided to not build the same thing because to me, each installation is another opportunity to try something new. And so I use it as a time that in my mind, we could do more research. In their mind, it's just it's a more personalized installation. So we took the basic same idea, and you can see here, it's a one hand, one person installation. As it's hot and wearing the glove, it's very curled. And if you put it into position and hold it there, it'll actually then start to flatten and constrict into its final position. You can see in the video on the left, we had one person on the inside, another person on the outside walking back and forth from the oven, passing the pieces, and you can see it go together. The silver parts are the thermal bimetal, the colored pieces are aluminum and are held taut. So you can see in the right video, the slack on the aluminum pieces that are first put in. And as all the thermal bimetal pieces start going in, it becomes very taut and very stiff. We work with engineers on figuring out the structural capability of the piece. And it was actually surprisingly complex, so complex that it crashed their program. And so the only way that we would know how much this load could do is by testing it with the old-fashioned way, putting sandbanks on it. But unfortunately, the owners of the tower don't want to do that. So we don't know to the very day, but we are estimating it to be about 2 tons that it can hold. So it's pretty good. You can see it was the bottom tier of a 5-tier tower that we ended up building. Another project, again, going back to these geometries, the biology, here on the right, there's this radiolarian, on the left, there's this kind of spherical flower. They're a part of the inspiration of how I think about things and put things together. And so in this case, it was very connected to Buckminster Fuller's dome, you can see here, which is also about that geometry and also something that influenced his work. But very directly, it was a way that I can use that same type of system in the previous project, but in a continuous surface. And it's continuous because in a sphere, basically there's no edges to it. So it just goes around and around and around forever. And therefore I didn't have to worry about what's going to happen at the edge. It would just be all surface. So in this idea, you can see here in the blue conditions is a cold material. That's where the thermal bimetal is. When we heat it up into the red configuration, it then gets really tight and small. We place it into that pentagon position. It cools down and expands into position and therefore pushes all the pieces together and starts to allow us a way to assemble a sphere. And so you can see here, and I just show the sequence just to give you an idea of the type of work and study models that we go through. The sequence of models that we go through testing and trying to figure things out. We use any kind of materials we can get our hands on. We have to color code it to know what we're looking at and start scaling up some of these spheres. So this one's about a 3-foot diameter. We did different variations on this. All the curled pieces or the curved pieces are bimetal. All the flat pieces are aluminum. It's hard to see the difference, but if you look really carefully, you can. And the same thing is here in a different configuration, but they're all using that same geodesic dome idea. And then the third, again, the curled pieces are bimetal and the straight ones are aluminum. And the idea, again, like many of our projects, is we're trying to make this thing be assembled using no fasteners, and that is all being held together by its own structural system. And then we go backwards sometimes too, because we have other ideas. And so this was done at the very end to test even another idea so that we can interlock and weave the whole thing together. And then we usually do an installation. And so this one was in the LA Municipal Art Gallery near the Hollyhock House in Hollywood. This was our final model that we installed. This is a 9-foot diameter. What you can see is all the colored pieces are aluminum again here to differentiate, and all the silver pieces are thermal bimetal. We ended up rebuilding this for the South Coast Botanical Garden. I put this video in there because to me, it's actually very meaningful structurally. You can see that the sphere is actually very soft. The bigger and bigger it gets, it's just floppy everywhere. And the second that we put in that last piece, it just stiffened up beautifully because again, the reliance on this continuous surface made it very important. And here's its final resting space. It's kind of nice to be part of a botanical garden because they think a little differently of art and life because their garden is always changing. And so I convinced them that the sphere can also change too continuously. So we're using it a little more as an experimental level and periodically changing out some of the infill and doing other things to it. And so they like the idea because it kind of matches the theme of their garden. That one person construction idea went a step further to self-assembly systems. And you can see here, we thought, well, why do we need one hand and one person? How about 0 hands and 0 people? And so just by using temperature, we started putting together these little pieces. And you see this one's very, very tiny, but was a very exciting moment for us. And since then, we built other kinds of things. This is actually a wheel that we put together, and the idea was that it was a wheel to a flat pack vehicle so that virtually we could actually make a whole vehicle and energize it just by opening a package and putting it in the sun. Climate and energy, and this is where our project for Cal State Long Beach actually exists, I think in my lecture at least, but not just in the climate and energy area, but this is what was a part of what was very important to us. Keep in mind that buildings in the United States take up, or in 2012, when this was done, 47.6% of all energy, more than transportation and industry. This is a tremendous number. And if you break that down, HVAC, which is heating, ventilating, air conditioning, took up 45% of that. Lighting and equipment were the other two, but 45% was a big deal. And so my attitude was, again, concerned about all this climate stuff. If we could just take that down by some percentage, we've made a very big deal because of the percentage of all energy use is dependent on it for buildings. So, this became a very big target for me. And even over the years, and this is more in 2019, these numbers have improved a little. They still are tremendous, right? Still 40% for buildings is still a lot. I mean, but how much is going into buildings to really save that energy use? We hear a lot about transportation and industry, but unfortunately not a lot about buildings. In addition, we have the heat island effect in cities that many of you I'm sure heard about. The hard surfaces in cities are not allowing cities to cool down overnight the way it should be, and that the way it is in the rural areas. And so since it's not cooling down at night, it gets hotter and hotter every day. As the temperatures rise, you can see we end up using more air conditioning. And air conditioners, in order to cool up the interior of a building, actually send off heat into the atmosphere. And so what happens is the more you use air conditioning in all these buildings, the more it contributes to heat island effect also. So it's a really, really bad cycle. In addition, keep in mind that 9% of all US energy in 2018 was used on air conditioning. That's a lot of energy just on air conditioning in the United States. 12% in the total, for the commercial sector, right? And that's a pretty abysmal number. So again, if we can bring down 1%, 2%, any percentage of this, that again will make a huge impact on greenhouse gases. I look back to other type of behavior systems in nature. Here, the social weaver birds, they build these huge nests and they're extremely resourceful. You can see building nests even on telephone poles, but they build these communities, which is very smart. And depending on where inside this huge nest, hundreds of birds live, where they are in their life, if they're actually laying eggs or if they're juveniles, etc., have a position within this nest system. And so the center of it obviously being much more warm than the outside or vice versa because of insulation. And this behavior therefore builds this community that can exist in actually very difficult climates. Termite mounds also are very smart too, right? They don't need high technology. They have a system of ventilation inside these termite mounds that are very automatic. So termites, in order to control the temperature in their mounds, are able to plug up holes when they need to, right, to gain that heat, and are able to open up certain holes to get natural ventilation through the entire system. It's a very, very smart, intelligent system that they use. So using some of those very low-tech passive techniques, a lot of that influence my work is, why can't we do this as humans? Why are we reliant on all these computers and all these high-tech things that, as you know, often fail? And so I started looking at these windows. Here's the big problem on the left. You see the floor-to-ceiling windows, the 360-degree views. Everybody wants this, everybody loves it. But the reality is, you can see standing in the sun versus the shade will still be a lot more hot, and you have to blast the air conditioning to cool these spaces. We have low E coatings on windows. That's the common thing you see everywhere. But what you don't realize is these low E coatings are very dark, right, in comparison to what clarity is. And what you do is you lose that color spectrum, you lose daylighting. There's the option of electrochromic glass you see on the right, where you can control it by computers and wiring. But a lot of them turn a terrible blue, which again, you may not want to be looking at all day long when it's sunny out. We have blinds too, and everyone thinks by using the blinds, that's a cheap way to do it, but the heat already has gotten in the building by then, and you still have to use air conditioning. And in addition, on the right, you see those blinds, when you finally do close them, are going to cut out a huge amount of the view. So InVert self-shading windows is the product that we're using on this project. Blocks the sun, and it does so by using these very small pieces that are inside the cavity of a standard IGU or a double glazed system. They flip over, and what you saw on the right, they do not constrict the view when they're opened or closed, when they're neutral or active. What it does is it uses this flipping geometry, where you can see here when it's cold, it's in one direction, and when it heats up, it flips over into the other direction. And by flipping into that hot direction, will block the sun from coming into the building. I show some of these things. These are very early renditions of it. Some of our first things that was very promising of just getting the geometry to flip. You can see the plastic frame is very, very early. The shape is very different than it is now. We changed a lot of the networking. You can see here moves to a metal type of networking, a slightly different shape to the pieces. We went through so many different iterations of what those piece shapes can be, what's going to work for both flipping and then also for shading. And then we finally came to this is near the shape that we have now, because we were able to get a large amount of coverage of shading from a very small piece you can see here. This is a very early video, time lapse for a single day. You can see how they flipped over in the morning when it gets hot and when they actually flip back over in the evening. It's orange because although this was done a few years ago, we didn't realize it. We filmed it when there was another fire in Los Angeles, one of the other wildfires in California, and the skies were orange that day. So we have the ability of making a gradient out of the system. You can see the pieces at the top are bigger and the pieces at the bottom are smaller, so we can control visibility through the system. But here's basically the current system. You see that they're all more uniform elliptical shapes. They flip over. A lot of people equate them to being like butterflies in the window as they flip over, and that are very mesmerizing and soothing to see when you actually stand there while they're flipping over. This video, you can see over the course of a day, how they flip over in the morning when the sun hits it. They look very white here, and that's, again, the color you can see on the outside of the building. And then at the end of the day, they'll flip back again and still allow light to get in. So variations, it's kind of nice if you think about that video I had earlier of the building changing throughout the day, and depending if the cloud's on it or not, that the building itself can potentially change and not be the same at any time of day. In the winter day, they will not flip, especially when it's cool, and you can see it allow the sun to come in to passively heat the interior. And then on a summer day, you can see how it flips over. The visibility stays about the same as you look through the window system itself. But again, I think it'll go through maybe again here. The shading on the ground will control the amount of heat gain in the building and therefore reduce the amount of air conditioning. We started putting colors on it, and that's what we're going to do for the project. I'm going to show in a few seconds. And we've gone through a lot of extensive testing for it. So you can see here the testing site in Fresno throughout the course of the day, how they do the testing and control how it is always facing the sun in the worst case scenario. And we've gotten several awards this past year as a product and a lot of support, which we're very excited about. And started to talk about how we're going to put this in for the Cal State Long Beach project. So here you can see is the beginnings of it. Our idea is is to use a shipping container. Now, knowing that the shipping container, there's a long history of it through the port, and the fact that it's a recycled, reused container, even though it looks pretty good here, it's nicely painted. We are partnering with one of my friends who goes by the name Yalu. And she's an amazing artist, a video artist, and has allowed us to use some of her graphics on that container. And you can see here in the rendering how we're going to try to use that graphic around the rendering and actually use the colors through the windows. You see 4 windows on the front to extend that graphic in a pixelated way. Here's a closer up with it. Again, these are just rendering. We're in the middle of finishing up the windows right now. Here you can see the pixelation, the color pattern that we're planning to put on the windows themselves. And then the idea is on the back of the container, we put these 2 little portholes that you actually can go up and peek through, and you'll be able to see through the inside of these windows without entering the entire container. So just to give you a sense of it, we're in the process of manufacturing it here. You can see we're 3D printing some of the clips that you see on the left that go and hold the thing together. Esther here is putting those clips together. We're painting the pieces as they are being prepared to go in the window system. sanding down what we call the network that holds all the pieces together. Testing them, we just have frames that we test them on to make sure that they're working for quality control. We also test them outside to see how they behave with the sun, and continue working on it. So hopefully we'll get it in before Thanksgiving, and I'll be able to see it at that time. The last project I'm going to share you is things that I'm working on, because a lot of people always ask me, well, what are you working on now? And something that I'm also excited about. Again, it overlaps with many of the things that I've done thus far. I see, there's an equation of architecture with our food culture too, historically, on a very simple level. In the olden days, food was for fuel, if you think of it that way. Then as culture developed, there's a whole period of food for gluttony. Some of that probably still happens now. But more currently, the attitude to food is that it's for nutrition, right? And that this healthfulness is the idea of food and how we should be eating. Architecture is very similar, right? Back, way back then, architecture was just simple shelter. Then there was a period of architecture for luxury, right? This really flamboyant period of architecture that again lingers today. But more recently, this attitude of architecture for wellness, of how we're looking to architecture to be part of that entire system. And so the project that I'm working on is basically trying to look at how we can deal with some of these real big problems of a city through architecture, in this case, making smog eating panels. And the idea that I have for this is that here's the typical city, right? A very, very simplistic diagram. And all these surfaces that you see in pink can be used and should be used for the city and not just for the interior occupants or for that building's owner. Instead of being a way that filters light and brings in views as well as branding for a building, why can't these surfaces be used for the city? And so that's what I propose, is how to make these panels basically filter smog and contribute to public health of the city. The smog sits at the very bottom of what's called urban canyons, right? They drop as particulate matter, and unfortunately, that's where all the pedestrians are. So the simple idea is trying to make this porous system of panels so that the air can actually pass through and filter, and therefore filter the air at the very lower areas of the urban canyons. So just very quickly, we're building wind tunnels. We're working with aerospace engineers on this. You can see one of our early prototypes of the type of one of the tubes that's going to ventilate and filter. It's inside a wind tunnel, and you can see our simulation modeling below. Early developments, early speculations of what panels might be and might work like, and how they go inside and outside these tubes. And the whole idea eventually is to build these little fresh air pockets that are bus shelters in cities around the world. This is where, again, some of the people sit and wait for long hours and get some of the worst quality of air. So as a reversal, we're trying to make these bus shelters as the freshest places to sit and the cleanest air in the city by making these surfaces and proposing these bus shelters. And then finally, the other areas in mental health. This is a project that we do in our office that's completely fun using the bimetal. We make these little critters. You can see they're fun. They have characteristics that are, that are very personable. They're cute. They make you smile. And so after doing these, I realized it's like, wow, we can, if these little critters can make us smile, why can't our architecture do that too when we see it? If it's going to be dynamic on the outside, if I'm proposing that we put these bimetal things on the outside, why can't we make people smile? And so this project is trying to, again, the goal is to make people smile. And if we can do that, if we can do that for one person, if we can do it for 10, we can do it for 1,000 people in a city, we can actually start making people smile more. It brings out endorphins. Studies have shown that it raises the level of happiness in people. And if we can do that, then we can possibly raise the level of happiness of a city. So the idea is how to get this gesture without making a person's face, so that people can actually react and somehow get that sense of this gesture of smiling. So that's something else that we're working on as well. But I do want to leave you with these last few images because they're just very, very compelling to me. An artist or a photographer, Richard Barnes, has taken these photographs that are so, they speak to me so much because of the level of the biology, the history, the human intervention, the ecologies of it. Is it wrong? Is it right? Is it beautiful? Is it ugly? I ask myself these questions looking at the work. They're so compelling to me that I can't stop looking at them too. And ultimately, one of the photographs that I end with is also one of his, which is this Flayed Man, which again, remembering a slide that I showed previously, flayed basically means skinless, right? Is the fact that the skin actually is removed. And so we have this flayed man in the front of all these animals moving in a direction who are all skeletal, and thinking very carefully, philosophically, what the meaning of this is. So I leave you with this photograph and my business card. So that's basically it. Thank you.
Fun business card. Doris, thank you so much for the illuminating and inspiring presentation. I think I speak for many of us when I say that climate and energy are very much on our mind, especially in California. And your projects are so creative and innovative in their approach. What great hope for the future.
Thank you.
And I hope you all come view the installation at CSULB on campus when it is up. So I'm going to open it up to the Q&A portion of this evening. I ask that everyone please remain muted. And if you'd like to ask a question, you can physically raise your hand and I'll call on you, and then you can unmute yourself to ask your question. And also feel free to type your question into the chat box if you'd like, because I know not everyone has their video on. So I hand it off to you. We have a question from Chris Allegria. He says, I would like to ask Doris key ideas she would like visitors of Smartbox to leave with.
That's actually a very good question. I guess, you know, when I did the Bloom project, the outdoor project, that was the big sundial. At that time, you know, I consider myself an architect. And at that time I had people come up to me and said, wow, I really love your sculpture. And I kind of looked at them thinking, it's not a sculpture, right? But then I realized, you know, as long as these things could speak to people on different levels, as long as they take a moment to, you know what I mean, look at it and think about it, if it's for art, if it's for science, if it's for engineering, if it's for architecture, to me, I think that's actually quite important for people to just take away what they, you know what I mean, they get out of it. And maybe that's why I feel like a lot of my work has this level of, you know, multivariable qualities to it so that it can speak to many people. If I were there and speaking to the person and explain to them, I would tell them that art can be technology, right? And that art can be operable and dynamic, and that, you know what I mean, it can be engineering, and it can be architecture, and it can be a lot of these things. But it's always hard because keep in mind, the pieces don't necessarily move at any time of day when you're there. If it's a hot, sunny day, and it's sunny from, 10 to 2 o'clock, none of the pieces will move. They'll just be in the hot position. You need to be there at a time where the temperature actually is changing, or the sun is going down, or you know what I mean, certain times of day. And so I think a lot of people come up there and say, oh yeah, well, and they don't realize this dynamic, and they're looking at us like, oh yeah, well, that's cool, right? But then other people are there at a completely different time and they see something different. And so that's kind of the nice thing about it too, is that it is changing always depending on the weather and what is happening. So I hope that answered the question.
Thank you. Another question from Christina Newhouse. Will the smog filtration system, how is the particulate matter removed?
Removed? There's two ways. The shapes that we use is from a principle called Bernoulli's principle, and it actually narrows sort of like hourglass into a neck. And in that neck is where we'll have filters themselves. In addition, the forms are going to be 3D printed and combined with a material called titanium dioxide, which is known to also remove gaseous type of materials of smog. So there's the gas level, and then there's the particulate level, the material, right? The particulate is going to be taken up by filters, the gas by the titanium dioxide impregnated into the surface area. So again, we're trying to make it so that, we decided to use 3D printing because I believe that 3D printing is a kind of technology that can be used anywhere very soon, right? It's not a kind of technology anymore that has to be used at a factory and super, super expensive and only special people can use it. 3D printers are getting cheap enough that you can buy parts and build it yourself. So if we can use these 3D printers, and if we can hack them, which we're able to do now, we can actually start using local soils to 3D print with any materials that are local, and therefore do it anywhere in Asia or Africa or Australia or anywhere at a very, very low cost. So the idea is to ultimately be an open source system that can be done anywhere and help everybody.
I have a few more questions. This is an interesting one and it has several questions in it. Christina Valentine asks, you differentiate luxury from wellness, but isn't attitudes on wellness today also an aspect of luxury? Considering that the objects that are sold for wellness are often out of reach to those who are in low income areas. And often innovative architecture by policy is often relegated to areas of wealth in cities. Are there ways to create socially equitable architecture?
Well, I think that's actually a really good question and a huge concern because, this type of technology, the people who are having the lung disease problems are in the lowest income brackets of the city. They're the ones who are living right next to the highways and the freeways. They're the ones who are standing and waiting at buses and shelters. So they're the ones who are pedestrians in places like Los Angeles too. And they're the ones who have the schools that are very close to smog areas. And so in order to really carefully think about this, we have actually a very cross-disciplinary team, which include policymakers. So we have policymakers on our team as well as preventive medicine people to really consider how we're going to use these types of panels. So on one hand, we're working with the aerospace engineers because the technology is again, passive, innovative on how we're going to build it geometrically. On the other hand, we have the policymakers and stuff to make sure and to help us and guide us so that we can get these things in the right places. So one of the targeted pilot places before we make the bus shelters is to include it in some of the target areas of playgrounds and retirement homes that are actually near highways in Los Angeles. So hopefully it will not be for luxury. Now, the presumption is if we can make it for, anybody at a very, very low cost, these things will also be available for anyone who obviously pays for it and is a higher income. It can be everywhere. And that to me is not of concern as much as trying to get it into these areas where people really need it.
Thank you. I see that we have a question from Michael Davis and then another from Josie. Michael, you can go ahead and unmute yourself.
Well, the question I have really isn't so much of a question as I live in San Pedro, and we are surrounded by the harbors of Long Beach and Los Angeles. And the particulates down here are extreme. And there is a black soot that gets over everything because of the diesel trucks and so forth. And I know there's been some movement forward with both ports. Have you done any analysis of the port or any areas like that where you just get high levels of this type of concentration of pollution? And in particular, it's close to the city of Wilmington, which is really in very close proximity, even closer than myself, to this type of diesel fuel and idling of ships and so forth. Have you thought about how this might work itself into rectifying some of those issues down here?
To be honest, I don't know. I mean, it is a very serious problem, that and around all the refineries, you know, in the whole Southern California area. To be honest, we haven't targeted that specifically because what we're looking at is trying to look at areas that are higher density with the population, right? Especially the ones who are pedestrians who actually spend a lot of times outside. Now, it doesn't preclude that, I think. I mean, I think eventually it can, but in the urban areas, we actually have a lot more wall surface area to cover, and therefore try to use that architectural surface for something like that. In other areas where it's more horizontal or doesn't have a high enough density, it's hard to actually use that kind of technology. You probably, in those areas, I would assume it'd have to require something more mechanical and more energy to clean those airs. It's bad. I agree.
Well,
but small steps.
Well, one of the things that is tried down here is putting, you know, some sort of vacuum system on ships when they come in, which is, you know, kind of a ridiculous thought. But I was just wondering if this technology might be something that could be incorporated into shipping technology or trucks or catalytic converters or those types of things. It seems like it might have that way. I'm fascinated with what you're doing.
That's actually interesting. I would say that it would work great on something that would actually move, right? So our hardest part, you know, so it's kind of funny because the way that I convinced these aerospace engineers to come on this project is they thought it was so groundbreaking to think of a static or stationary thing be aerodynamic. Like they're working on project, you know, on vehicles, on airplanes that are moving at Mach speeds, right? And trying to reduce turbulence on the surface and the engine parts and all these kinds of things. And so when I approached them, I said, well, we want to do it on a building and we're looking at 3 to 5 miles per hour, you know, I mean, winds. And they're looking at me thinking, wow, that is radical. That's like crazy, you know? And so they got super excited by it. But certainly if we put this technology on something that actually moves faster, you can actually filter more, right? So even if we put it on parts of a boat or a train or a vehicle, the surface can automatically start cleaning. And it's the low level of winds that we're trying to use, or like I said, the drafting or the plunging of cars and vehicular traffic or buses and stuff like that, that we're trying to, kind of draw and scum off of to try to get that air movement. It's a hard thing. But I think you've given me more ideas of how to do that, because why couldn't we? Why couldn't it be installed on ships and those types of things? And a lot of the ways that titanium dioxide is cleaned is by dew or rainwater, or that the part that actually then scuffs it off and it can start all over again. So it's a problem, it's scary. I'm sure some of you have read about too. I read about this many years ago, about how much money was going into trying to change our atmosphere by shooting things up into the atmosphere to control climate change and, greenhouse gases and the shade cover. And more recently in the news in the last couple of weeks, they're actually talking about this as a real thing. And it seems frightening that we've actually gotten to this point, that this is how we have to control ultimately climate change. It's bad. And so when you say too that the smog is so bad in certain areas, it is true. How did we get to this place that if the fix becomes tremendous and so difficult? And we have to think of crazy ideas to even do that.
Well, they're not crazy.
Well, now we're starting to get used to it. Now we have to, shoot weird aerosols into the atmosphere to make more cloud cover.
Yeah.
That's kind of frightening, though, because I was reading articles that says that what if things go wrong? I mean, there's no test for this. You can't test it out. The test is the actual doing it.
Right. It's like an atomic bomb blast.
Right. I mean, let's test it out. Let's see if it works. Hope you gotta cross your fingers. Luckily, I don't work in that area. It's again, trying to think in a more smart, balanced way to living and how we should behave, as opposed to keep pushing things to these extremes.
Looks like we have question from Josie and then a question from Karen. From Josie Glassberg, have you been in touch with any cities that are ready to adopt these surfaces or pilot them right now for cooling?
Oh yeah. The thing is, everybody's ready to pilot. We are so far from piloting. If you can see, it just takes so long to develop these things. I would suspect it's probably going to be another 3 years before we actually have a real working prototype. But if you know any money sources or funding sources or facilities or help or anything like that, they're welcome, because that'll speed it up, definitely.
And then Karen, did you want to ask your question? You can go ahead and unmute.
Oh, it's a good way to begin by unmuting. I think I'm shifting my thinking from some of the practical applications, which are the really exciting things, to something maybe a little more poetic or metaphoric. I'm just struck thinking about the history of architecture and how in modern architecture in particular, Corbu called the house a machine for living, and Mies van der Rohe creates these skyscrapers that are like skeletons with what he called the glass curtain wall or a skin, but they weren't skins. They didn't breathe. And the Seagram building, the people inside working at it would go nuts, and they had to work out a system to how far you could lower the shade at this hour of the day so that it wouldn't disrupt the aesthetic of the all over building. So I'm so inspired, I guess, about thinking of what this does to the way we talk about architecture. We think of it as dividing an inside from an outside. Mm-hmm. And when it's a skin, when we think of that machine in more of a, I don't know, a cyborg way, or with complexity theories being really interactive, it's not a division or a boundary like that. It's layered, it's a different kind of space. Like you would, I think it was the view of the window with the kind of shift that I know you wouldn't see at once like you would in a light space installation, but you would live in a very different dynamic of no longer thinking that you're just exactly inside separate from an outside, which is a false binary. It just makes so much sense if we take this metaphor of the building as not just a machine and then shooting things into space and using machines constantly, but we think of machines in a more cyborg, hybrid way with different systems interacting of the human and the technology as tools. This gets really exciting about how to think of I guess it's just all the unrest we have right now, the sense of how all these systems have to collaborate,
Mhm.
to coexist.
Yeah, no, I
Don't
think
have
you
separation.
you
That's
hit
why
it.
communities
Yeah,
happen.
you're right on. That is, I mean, I could go on a whole lecture about talking about these systems, but you know, those early modernists that you're talking about, I mean, they meant well, right? Because that's when this float glass came out and the long spanning steel, and we're able to do these things that we never could do before, which is ultimately opening up the wall, right? And making people feel like they're part of nature. And so unfortunately, the same idea has continued and has been, you know, I mean, emphasized through real estate and through all these, you know, I mean, different things, that is what connects us to nature, is that open up the walls, make these huge windows, and as long as I can see everything, I'm connected to nature. But the reality is, it's not good, right? There's nothing natural about that. And just because you can see it, the reality is you're hermetically sealed from the nature. In most cases, as you know, you go into these buildings, you can't even open the window.
Right.
You know what I mean? You can see through it and sort of see through it. It's very, very dark. Imagine a place like in Las Vegas where, you know, it's like dark sunglasses everywhere, really dark. And you can't open a window, because if you open it, it will basically compromise your heat, your entire mechanical system, right? And it won't work efficiently. So over the years, it's become and developed into a more capsule system. That the skin of a building is like a capsule. It seals us off from everyone else, everything on the outside. And even though we think we're connected to nature, it is the absolute opposite. So this idea of the skin being much more porous, in my eyes, this doesn't mean that it has to be visually porous or visually transparent necessarily, but porous in the sense of letting air in. We need to, you know, I mean, everything from the ventilation to the light to the color to all these things, you know, I mean, and understanding how the skin is much more of a mediating surface between the inside and outside than a capsule of sealing or fully transparent, because it's a falsehood. You know what I mean? That we all believe that, oh, just because I can see things, you know, it's actually good. And so there's a whole education, I think, to the public for us to really understand that transparency, full transparency, isn't what we really want, actually. And that what we, especially on a healthful wellness level, right, is what we know, what we need is something that's just more porous, but on a multivariable level.
Something that breathes.
Something that breathes somehow. And again, you know, and the reality is, in a lot of office buildings, I'm sure you've all been to, you go in them and all the shades are drawn, right? You go in them, they have these beautiful views, yeah, that they're paying for, but then the blinds are all, you know what I mean, shut down, and they cut out as much light as possible, and they cut out view. And in the end, you know what I mean, when you show up, they'll bring up the slides and say, look at our great view, and then put it back down again, right? So it's kind of a, you know, it's a certain amount of dishonesty that we live with, and is unfortunately driven by the real estate, I mean, businesses of what
Yeah.
we think we want.
Well, we live in screen culture, right? From one screen to the next. And so that's our idea of connecting with nature.
Yeah.
But I even think on a political level, somehow this idea of adaptation, the things you get with complexity theory, the kinds of adaptation in systems is the way that you could maybe finally get cooperation. But, well.
And so I bring it also back to art. I mean, a lot of people, as you show, I showed a lot of these projects, and they're all being supported and sponsored by art museums, right? I also get engineering grants and, you know, I mean, government things too. But I especially appreciate the arts ones, because I think it's through the arts, and more recently, that that I feel that people are much more courageous, much more risk-taking, much more forward-thinking than a lot of other industries. And the fact that there's the ability to mix art into everything. What is the medium, right? Is it the traditional sculpture or painting and, you know, and that type of thing? Is it the newer video, you know what I mean, moving art? Or can the medium be architecture or technology itself, or, you know, microscopic or very big, and, you know, where does it stop? And so I'm a strong believer that actually it's in everything, right? And so, which is part of why I think, you know what I mean, I'm here and talking to Paul and Christina and everyone, because I think the nice thing is we all, you know, start to realize it can be, and it may be something very different.
Thank you.
Yeah, thank you.
On a similar note, a note from Christina Newhouse, we're not going to technologically innovate our way out of the climate crisis. Each new technology consumes more resources. We need to simplify to go low tech.
Yes, we need to simplify. In some way, in some weird way, I feel like this pandemic, and, you know what I mean, even in my life has made, you know what I mean, has made everybody start to think about some of these things. I hate to say it, it is true that I've bought a lot less things and have not contributed to the economy by controlling my consumerism. But then I realized, why did I need all this stuff anyway? Maybe something happened wrong there in the first place. Like, why was I spending all that money? I don't know. You know what I mean? Instead of thinking about how we should get back to what that is, you know, we got to wonder, what were we doing? So.
And we have a question from Paul.
Yeah. Doris, first, thanks for just talking with us all and kicking off this lecture series. I'm so grateful to use my brain in this way, thinking about all the ideas you're introducing to us. It feels good right now. And I think just thinking, as you were just making your comments, thinking about just how dangerous lithium mining is, and we're all counting on these batteries to store energy from solar, but we're destroying the earth, mining the lithium to store the energy, right? So that sort of leads me into a different line of questions for you. You know, as director of an art museum, I'm very interested in how we understand what contemporary art is. And as you were talking, I was thinking about, you know, I took 2 architecture classes in grad school. One of the things that I think most of us know about the sort of Gothic era is architecture. And the 2 things that we all remember, I think, pretty well are actually structural elements engineered to make something possible. So flying buttresses and the gargoyle waterspouts, right? Because they were they had to direct water off of this limestone so that these buildings wouldn't melt, right? So to speak. And so I'm really fascinated by how your project is sort of a model of what contemporary art can be, right? And I think some people who maybe struggle with defining what contemporary art is can actually make that connection between a technology that's, what, 1,000 years old. So I'm really fascinated by how you're modeling both something old and as something new. And so that's a comment. And then my question really is, another thing that sort of often divides art from craft or from design is decoration. So we often think of the flying buttress or the gargoyle as decoration, but it actually has a purpose. And your smart box for campus has decoration on it, but the decoration actually reveals what this is, right? That Yalu's design is based on skin, and that's, as we learned at the start of your talk, that's what you're inspired by. So I'm wondering, you know, how you got to Yalu. I mean, sometimes art innovation is by accident, sometimes it's by purpose. How intentional was that? And tell us a little bit more about this wrap that's going to go on.
Okay, well, I guess, first I want to respond to what you're saying about decoration. I actually thought about that too. I actually think a lot about my work, and I actually use the word ornament because that's a word that we use in architecture. On one hand, I feel like my work itself is very ornamental, but the ornament is the surface, is the actual material and technology. And that is just inherent and you know, infused into the pattern making and the way we make it. And jumping over to Yalu, again, literally, I mean, I actually met her because we were both doing a residency at the Headland Center for the Arts at the same time. And she actually does these video installations. If anyone has opportunity to go look at her work, they're just crazy VR type of installations where you put the headset on and you actually can experience these worlds that she fabricates that are really just so outrageous. She's much younger too, and she does these things. And I mean, I'm looking at these things again, and I remember looking at them for the first time, wondering, is this really ugly or is this really beautiful? And is that kind of moment is like I'm moving between. And when she's describing this stuff, it's like, that's supposed to be a fruit that I'm standing next to, and where, you know what I mean? Am I old fashioned or am I really digging this? Or, you know what I mean? It was that kind of suspension that makes it so hard to judge, I think, which I really liked. And I use the word judge as opposed to be critical of, right? Because that's kind of the visceral feeling you just first get when you're sitting there going, what's going on here? And so, you know, we spent time together and, you know, talked about it. And I actually never thought that we'd overlap in our work. And like many things that are, you know, serendipitous. And when it came time to thinking about the graphics for this project, you know, we talked about it a little bit. I didn't, you know, what we put on for our early images was just some really easy, simple graphics that ultimately, you know, mean referred or have reference to like Martha Stewart type of looking things, which to me is just graphic, is kind of beach blankety looking. And when I stopped to really think, gosh, wouldn't it be great to have some real, you know what I mean, art on this project that would somehow camouflage the surface, right? So that it wouldn't look as boxy or wouldn't look as container-ish, and if anything, would really make your eye move across it. I actually thought of her work. And because I knew her and I, you know what I mean, was hesitant and I knew she's so busy, we talked and she was super excited about including her work on the project and was more than happy and willing to share it with us for this. So it turned out to be great and I'm super excited. And then it gave us the ability to run her artwork through the window and through our system as well. So and now that you say this thing, the decorative or the ornamental, it makes me even more excited because I do, you know, again, a whole separate other lecture about, you know what I mean, ornament and the meaning of ornament and how useful or functional ornament can actually be is a very big part of my work too. So, sorry, they're kind of long-winded answers, huh? You ask these questions, it's like, oh my God. As I was telling, you know, I mentioned before, it's nice to stop and do some of these lectures because you become very contemplative about your own work and your own philosophy, and it's a moment of, you know, I mean, trying to get balanced and recentered again. And so it's a really nice thing to do.
Thank you, Doris. I think I can speak for all of us when I say we really appreciate these answers, and there's so much to think about there. One comment from Christina Newhouse: ornament is often tied to the spiritual, the eternal, the sublime. So if no one else has any questions, I think we'll wrap this up. I'd
Yeah.
like to,
Well, it looks like Marty Gonzalez has her
Yeah.
raised hand.
Yeah,
oh,
can you
sorry,
hear me? Let's see. Can you unmute me?
we hear you, Marty.
Oh, yeah, I was curious, when you have a building that has this installation, I understand how it works when it's facing the sun, but what happens on the inside with the artificial light? How, does that have an impact on it too?
No.
No.
No, especially nowadays because we have LED lights that don't give off heat. So our system only reacts to heat. So it will not react to any interior light. It's the heat of the sun or solar radiation or the outdoor temperature, ambient temperature.
Oh, okay, thank you.
That was the easiest one. Good question.
I'm simple-minded.
Yeah, no.
Thank you for that. Well, I'd like to once again give a big thanks to Doris, and thank you everyone for
Thank you.
participating.
Thank you. Thank you. They were really great questions. Thank you. And I really enjoyed it. I know the Zoom world is kind of a odd place. But thank you all for coming too and asking those great questions.
Thank you.
Thank you. So the next lecture in the series will be next Wednesday, November 18th at 7 p.m. And the speaker will be Maren Hassinger. See you all then. Have a good rest of your evening and stay safe.
Yeah, thank you.
Bye.
Bye-bye.